for you to have gone through some classes, some schools to learn how to operate this equipment. Were you taught on the job as it was being installed? Or?
Exactly that. We were taught on the job as the equipment was being installed. On the case of the bottle ship, we were not taught on the job as it was being installed. We were observers, essentially, at that point.
Who was it that was teaching you this?
Von Neumann, primarily.
Okay.
We talked occasionally with Tesla, but he was too busy to really sit down and spend much time with us.
So was von Neumann sort of the chief engineer?
Yes, he was a very strange breed of animal, if you will. Don't mean to call him an animal, but he was a very strange breed of person, because not only was he an excellent theoretical mathematician, in my view and some others, perhaps better than Einstein, but he was also an engineer. Einstein was pure theory. Von Neumann was one of those exceptional breed who could combine theory with engineering and figure out what kind of hardware had to be designed and built to implement the mathematical theory. Now this, of course, he didn't get the chance to do until after the failed test of March 43, I'm sorry. No, 42. These dates. When that test failed, because Tesla deliberately sabotaged it, and he did this for a reason. He was a very ethical man, and he felt that he could not risk the lives of the sailors in a test he was quite sure would put their lives at jeopardy. The Navy wouldn't give him more time to solve the problem, which he felt it could be solved. So he chose to sabotage the test, not have anything happen like produce invisibility, and not have anyone hurt. So when this occurred, namely, he sabotaged a few pieces of equipment so nothing happened. He says the test is a failure. I'm bowing out. I have other things to do. Dr. John von Neumann would be a very good choice for a man to take over. So everybody jumped on that, including the Navy, and accepted him as follow-on. So von Neumann says, well, I have to study this problem and see what went wrong. Well, he quickly found out what went wrong. But he decided he wanted to redesign most of the equipment. Not the basic approach, but he wanted to redesign the hardware. And, of course, he said this to the Navy and proceeded to do so. During this time, then, Duncan and I became much more involved, or other technicians became involved who had to help with the equipment. But, of course, there was a gap from March 42 to July 42, during which time he was doing more theory and deciding what kind of an approach he wanted and what he wanted to do in terms of those who understand the engineering. The approach that Tesla used was a pure analog approach, i.e. continuous signals, 4 different modulations on a stable continuous RF carrier, plus modulation on the electromagnetic generators, the fields that were being generated internally, which of course meant that the power out of the generators driving the coils on the deck was modulated with a special series of modulations. I don't recall much about what they were doing with that, except there were 4 frequency modulations, 4 modulations of different frequencies for the AM modulation, because it was not FM, for the antenna system. And this antenna system also required 4 RF transmitters, which were operating in conjunction with the preceding driving electronics, which produced a quadrature type of field, which was a rotating electric field set up in a quadrature antenna, which means there were 4 transmitting lobes, 4 transmitters driving it, with the associated electronics, which would produce a rotating electric field at a very low rate. As I remember now, the electric field was rotating at pi radians per second, which is 1/2 hertz. Frequency, which is to say, would take 2 seconds for the electric field to do a full 360 rotation. The magnetic field was rotating at half that frequency, pi over 2 radians per second. And the modulations on the magnetic fields were somewhat different. They also used 4 coils, so that because of the way the coils were configured and the driving was configured for the 2 generators, they could produce a quadrature field or rotating magnetic field. The modulations award determined the fact that you interlocked the electric field and the magnetic field in a certain manner, so that by generating those 2 artificially, you locked in with the gravity field.
Physically, how large was this equipment that was on the ship?
In terms Of which? The battleship, or in terms of the...
On the battleship, yeah. Was it quite significant?
Covered most of the forward deck.
Most of the forward deck?
Yes.
What about the back?
Nothing on the back deck.
It was just all on the forward deck?
It's all on the forward deck, and of course they had to put an antenna on up top of the highest mast, and they had to have 4 coils which were arranged symmetrically around the high antenna.
How large were these coils physically?
They were essentially the same coils they used later on the Eldridge. They stood about 7 feet high. They were wound as a single turn coil, copper tubing, about 1 3/4 inches in diameter, hollow, liquid cooled, because we're pumping enormous amounts of power through them. And the interesting part about this coil, it was tapered as a conical coil. See, Tesla had a very strange quirk in a lot of things. He liked to design transformers even, which were wound not the way we do them today, but tapered, a sort of a tapered conical coil. He said they were more efficient, and I believe there is mathematics today to back that up. But the coil on the deck was conically wound, so it was perhaps not more than a turn that size at the top, let's say about 6 inches. When it got down to the bottom, the single turn, if you will, which is a spiral, was about 3, if I remember correctly, about 3.5 feet broad, and had 1 feet connection on the bottom end and 1 feet connection on the top through the center. And of course there were 4 of these coils. So I remember counterclockwise wound, depends on your reference point, of course. And of course they were fed individually by 4 sets of cables. So those coils were quite large, and eventually he used analog. This is another interesting fine engineering point. Analog driving, there was no ringing problem, so there was no ringing dampening required on those coils. So when it was switched to the von Neumann approach later, they had to put damping or anti-ringing coils on the top of the coils, which were literally bodily moved over to the Eldridge. They used the same coils. But the generators they used, as I recall, all of that stuff was mounted on the decks of the battleship. Some of it was on the dock side. If I remember right, they had a diesel electric generator. That was dockside. The large generators, I'm not even sure how they arranged those now, because it was not the same configuration as they later used on the Eldridge. The Eldridge, you're able to design the ship for everything being built in the interior. But they had the 2 large generators. They somehow managed to synchronize them. At least they claimed they did. We never really proved whether they were synchronized or not, because the whole test was sabotaged. In the new approach, von Neumann wanted to use a digital, if I may borrow that term, a pulsed approach would be the more correct approach, but the more correct terminology, in which he had a 10% duty cycle, 10% on, 90% off, and he wanted to pulse it with very high power. He increased the size of the transmitters from approximately a 0.5 megawatt output each of the RF variety, that is 4 of them at 0.5 megawatt, to 4 of them at about 2 megawatts output, operating in essentially the same frequencies, 160 megahertz region, and of course with the modulation on that. Now I raised the question, remember this, I didn't think it was possible to generate that amount of power in the period around 1942-43 with the equipment then available. Well, it turns out, doing some research, as I ran across a book on the early radar systems for the Navy, they were generating tens of kilowatts and up to 100 kilowatts at frequencies up to 300 and 400 megahertz in 1940-41. The equipment existed, but it was not available to the civilian sector, put it that way. What they built for the military was always years ahead of what the civilian sector gets, and that held true for this. The magnetic aspects, of course, was quite standard, except the generators they finally built for the Eldridge, or DE-173 as it was known before they dubbed the name on it, were quite special in design. Each had 5 field coils. That's rather odd, and I don't know why von Neumann chose to have 5 field coils, and they had 2 generators, which had to be driven by the same motor set, not generator set, they were the generators. 750 horsepower electric motor, huge gearboxes, right angle drive. They mounted the generators vertically, that is the shafts were vertical. The shafts were about 8 inches in diameter, which they were monsters. The things were very